Good morning, everybody. Welcome to this session in the Union Conference on Diagnostic Assays, Quality and Accuracy. My name is David Moore. I'm one of the co-chairs today, and I'll be introducing the speakers at the start of this session before we go away and watch their talks, and then come back for questions, which will be led by my co-host, Petra de Haas. We have a number of fascinating talks today from a number of places around the world. We've got talks on the MolBio TrueNat assays, on the Sylvamp urine tests, on the XDR test in Expert Ultra, some EQA work on Expert Ultra, and then some work on MTB-RIF and the Expert MTB-RIF and Determine LAM assays being used together. And then finally, a talk about larger platforms for wider use in a more centralized way. Our speakers are many and varied. So we have Adam Pan-Nicholson from FIND. He's a senior clinical officer at FIND, who's involved in the planning and conduct of trials and many diagnostic evaluations. We have Dave Van Jagannath, who's a pediatric ID physician and assistant professor at UCSF, and who is working on child TB diagnostics, biomarker discovery. And his main focus is the End Childhood TB study in Kampala, which also happens to be where Peter Wamby, one of our other speakers, is working. He's a medical doctor who's doing his Master's of Public Health at Makerere, and he's involved in the same platform. We'll present some different data. Barry Kozlov has been working at the London School of Hygiene and Tropical Medicine for 12 years and is the lab head at Zambart, which is an NGO based in Lusaka in Zambia, at the National University of Zambia. And he's been involved in large-scale trials of HIV, TB, and now SARS-CoV-2. And he will talk about the EQA work that he's been doing. Mulu Alem is a TDR fellow from Ethiopia who's been seconded to FIND for the last year, or since January, sorry, and mainly working on Seek and Treat, but we'll talk about his diagnostics work. And then Margarita de Vos is a scientific officer at FIND, and she will round off our sessions. So with that, I think to minimize the amount of time that I talk and maximize the amount of time we've got for questions, I think we should go now to the presentations. Enjoy.
Thank you everybody for making the effort to attend this talk. It's great to be here. My name is Adam Pan-Nicholson and I'm a clinical officer at FIND in Geneva. Today I will talk about exciting results from a prospective multi-center diagnostic accuracy study to evaluate the MolBio TrueNat TB assays in a level 1 primary healthcare facilities and reference laboratories. I have no conflicts of interest to declare, except to say that FIND is a non-profit foundation that works with multiple partner organizations and receives funding from a range of different entities. The study was primarily funded by the Gates Foundation and the Indian Council of Medical Research, and was conducted entirely independently of the test manufacturer. The main findings of this study are that the point-of-care TrueNat assays can be used as an initial test or detection of MTB and rifampicin resistance in both a centralized setting and, importantly, in primary healthcare centers, and performance is comparable to that seen for Expert. There are many people who contributed to the success of the study, so I want to make sure I acknowledge everybody involved up front. The leads at FIND were Samuel Schumacher and Claudia Denkinger. Primary analysis was done by Aurelian Mace. Dr. Manjula at the Indian Council for Medical Research and Dr. Gamati and Dr. Tripathi at the National Institute for Research in Tuberculosis were instrumental in operations. Other site PIs in India were Dr. Patel in Ahmedabad, Dr. Bandana in Guwahati, Dr. Camila Rodriguez at PD Hindusha Hospital in Mumbai. The study was also conducted in the Ethiopian Public Health Institute under Abiod Meaza and Ephraim Tesfaye, and at UPCH in Lima, Peru under Dr. Cesar Agatha-Gil, and Papua New Guinea under Evan and Lavu with support from Philip de Cross at the Burnett Institute in Australia. The TrueNat platform is a battery-operated, portable point-of-care DNA extraction and micro-PCR system. It consists of a separate cartridge-based DNA extraction device called the TruePrep, and provides DNA eluate from sputum or any other specimen within about 20 to 30 minutes. 6 microliters of the DNA is mixed with primers and enzymes and transferred to a micro-PCR chip, which is run in the TrueNat machine and provides a result for the detection of MTB in about 40 minutes. We evaluated 2 chips for MTB detection. The first is the TrueNat MTB chip with an NRDZ target. And the second is a TrueNet MTB Plus chip with both the NRDZ and the multi-copy IS6110 target. If either test resulted in an MTB detected call, the remaining DNA eluate from the TruePrep cartridge was subsequently reflexed to another chip called the TrueNet MTB RIF-DX assay, which can detect resistance to rifampicin through the RPOB target. These assays are somewhat analogous to Expert and Ultra, except that DNA extraction and PCR are done on separate machines, and RIF resistance is only performed as a reflex assay if MTB is detected. The trial was a prospective multi-center diagnostic accuracy study with detection of MTB in both the level 1 microscopy center and in centralized reference labs. To give you an idea of the reality that not all of these sites were sparkling and clean environments, one site had a problem that rats would come into the microscopy room at night, and a rat actually chewed through the power cable to the microscope. Another site flooded when the roof collapsed. We enrolled adults with signs and symptoms of pulmonary TB. These non-converting cases who had received any TB treatment in the last 60 days only contributed to the RIF resistance analysis, whereas treatment-naive presumptive TB cases contributed to both the MTB detection and the RIF resistance analysis. We used a strong reference standard of 2 cultures performed on sputa collected on 2 separate days and phenotypic DST for rifampicin resistance detection. The comparator was both Expert MTB RIF and in Peru, Expert Ultra. We enrolled 1,926 participants in 4 countries: Peru, Ethiopia, Papua New Guinea, and the bulk in India. Analysis was performed on 1,764 participants, of whom 24% were culture positive for TB, and in these cases, 30% were smear negative and 15% were RIF resistant by DST. The primary analysis was diagnostic accuracy in the microscopy center. I've highlighted the tables for the columns for sensitivity and specificity, where sensitivity was between 73 to 80% for TrueNet, and specificity was 96 to 98%. Sensitivity for RIF resistance detection by TrueNet placed in the healthcare center was 84%. While overall performance point estimates were marginally higher in the reference lab, these were not significantly different between the 2 settings, demonstrating the appropriateness for use in a level 1 setting. In the reference lab, where Expert was placed, we can see that both sensitivity and specificity of the TrueNet assay was comparable to that of Expert. Panel A on the left shows performance of both TrueNet MTB and MTB Plus versus Expert. Panel B on the right shows performance of the TrueNet MTB RIF-DX assay for detection of rifampicin resistance versus Expert. Overall, the MTB Plus assay had slightly higher sensitivity and slightly lower specificity for MTB detection than that for TrueNet MTB assay, analogous to that of the Ultra compared to Expert MTB RIF. The Peru reference lab was the only site that had used the Ultra assay instead of the Expert MTB RIF. From the 93 TB cases in Peru, we saw lower sensitivity of both TrueNet MTB and MTB Plus than Ultra, whereas specificity was comparable. While these results are interesting, it is limited by a small sample size and should not be overinterpreted until replicated in other studies. Overall, the diagnostic accuracy of the TrueNet assays for MTB detection is comparable to that for Expert MTB RIF. And although the point estimates of sensitivity is somewhat lower in the microscopy center than that of the reference lab, these differences are not statistically significant. Importantly, specificity is not lower in the microscopy centers, suggesting that the open nature of the assay does not lead to a high false positive test result. Detection of RIF resistance was similarly comparable to Expert and Ultra. The sample size was too low to allow accurate subanalysis for diagnosis of TB in people living with HIV. The proportion of non-determinate tests was high at 5.6% and 7.8% for the MTB and MTB Plus chips, respectively, but not unlike that seen in early Expert studies. We did notice that the rate of non-determinate TrueNet MTB RIF-DX assays was highest when DNA was reflexed from a positive MTB Plus assay, likely indicating a difference in LOD between the MTB Plus chip and the RIF chip. A WHO guideline developed group reviewed these results and has recently given a recommendation for use of the assays as an initial test of the detection of TB and rifampicin resistance as a replacement to smear microscopy. We believe that the results shown here demonstrate that the point of care nature of the TruNat assays make it a desirable molecular test for uptake in countries who have not yet to date had high rollout of expert. Thank you very much for your attention, and thank you again to the PIs at the sites and all the staff involved, and of course to the participants and their families. I'm happy to take questions now or by email. Thank you.
I have no conflicts of interest. Thank you for having me today. My name is David Jagnoth, and today I will be discussing the role of silvamplam for the diagnosis of childhood pulmonary tuberculosis in Uganda. There is a critical need to develop non-sputum biomarker-based tests for TB in children. Lipoarabinomannan, or LAM, is found on the mycobacterial cell wall and is excreted in urine. While there is a lateral flow assay, or LF-LAM, it has not performed well in children. A next-generation point-of-care LAM assay, Silvamp-TB-LAM, or Silvamplam, has been developed, and studies in adults have been shown improved sensitivity compared to LF-LAM, but there has been limited evidence in children. So our overall objectives were 1, to assess the diagnostic accuracy of silvamplam for childhood pulmonary TB, 2, compare the accuracy of silvamplam to LF-LAM and AFB smear microscopy, and 3, to determine the added yield of silvamplam for children with unconfirmed TB. We evaluated silvamplam as a sub-study within the End Childhood TB study, an NIH-funded project to improve childhood TB diagnosis, and was done in partnership with FIND. The study occurred at Malago National Referral Hospital in Kampala, Uganda, with community referrals throughout the Kampala area. We included children less than 15 years old who were being evaluated for pulmonary TB and were not on treatment or prophylactic therapy. They underwent a standard clinical evaluation for TB, including respiratory specimen collection, and urine was collected by spontaneous void or urine bag. All children were followed up after 2 months, and those on treatment were followed up at 6 months. The main index test was silvamplam, as shown here, and was compared to LF-LAM and AFB smear microscopy. With the respiratory specimens, we performed expert ultra and culture and defined cases as confirmed, unconfirmed, or unlikely TB. We sought to determine the sensitivity and specificity of these tests, primarily comparing confirmed versus unlikely TB, but then also incorporated clinically diagnosed unconfirmed TB in the definition of TB, or the composite reference standard, or in the definition of not having TB, or the microbiological reference standard. So now moving to the results. Over 12 months, we included 113 children, of which a third had confirmed TB, a quarter with unconfirmed TB, and the remaining with unlikely TB. The median age was about 5 years old, and we would note a small number that were HIV positive, and the majority of the sample were underweight and enrolled from outpatient clinics. Also, the majority of samples were spontaneous void and few from bagged urine specimens. In our primary analysis of confirmed versus unlikely TB, the sensitivity of silvamplam, as shown here, was 51.4% and specificity 91.5%. In contrast, LF-LAM was almost 30% less sensitive, and that difference was statistically significant, without a significant difference in specificity. Similarly, AFB smear microscopy was about 20% less sensitive, and again, without a significant loss of specificity. Next, we considered the role of unconfirmed TB. In the composite reference standard, where unconfirmed TB was included in the TB definition, silvamplam sensitivity dropped slightly to 45.5%, and in the microbiological reference standard, where unconfirmed TB was defined as not having TB, the specificity dropped to 80.3%. In comparison, LF-LAM and smear microscopy sensitivity remained lower than silvamplam in the CRS, or composite reference standard definition, but with higher specificities in the microbiological reference standard definition. Now, in considering the additional yield of LAM testing among confirmed TB cases, this diagram shows the added yield of Expert Ultra, Sylvamp LAM, LF LAM, and Culture, with a number representing the additional cases of a given test over the other assays. We can see that LAM testing only added one case, and culture was still needed to diagnose 4 or 11% of cases. However, when considering also the unconfirmed cases, Sylvamp LAM was positive in 38% of cases and increased the yield over Expert Ultra by 18.2%. Notably, there were still 24% with negative testing. So overall, we benefited from a prospective design and well-defined cohort from both tertiary and community settings. However, we had some limitations. There was a low HIV prevalence that prevented a subgroup analysis, and as noted, the sample was primarily outpatient, and so further studies are needed among hospitalized children. So in conclusion, our main finding was that Sylvamp LAM had superior sensitivity to LF LAM and AFB smear microscopy for pulmonary TB, and should be viewed as a useful adjunctive tool, especially if unable to do sputum-based testing or when clinical suspicion remains. This also supports LAM as a promising biomarker for childhood TB, and further efforts are needed to improve the sensitivity for children. I wanted to acknowledge and thank the participants and their families, the entire End Childhood TB team who was critical for completing this work, as well as the referring clinics from KCCA and IDI and our partners at FIND, my fellow lab mates, and our funding support. Thank you, and I look forward to answering any questions.
Thank you, everybody, for making the effort to attend this talk. It's great to be here today. Today, I will talk about the exciting results from a prospective multi-center diagnostic accuracy study to evaluate Cepheid's Expert XDR assay as a reflex test for detection and resistance to isoniazid, ethionamide, and second-line injectable drugs. Overall, the assay has high accuracy, a low rate of non-determinate results, and user appraisal was very high. Cepheid launched the Expert XDR assay in July, and WHO is now planning a review of the data in December. I have no conflicts of interest to declare, except to say that FIND is a non-profit foundation that works with multiple partner organizations and receives funding from a range of different entities. This study was funded by the KfW Development Bank and was conducted entirely independently of the test manufacturer. FIND was sponsor of the multi-center study, with a particularly important technical and project management roles provided by Sophia Georgiou and leadership from both Samuel Schumacher and Claudia Denkinger. Dr. Camilla Rodriguez was the PI at PD Hinduja Hospital in Mumbai, India, and Dr. Mainidu provided leadership at the National Institute for Tuberculosis and Respiratory Diseases in New Delhi. And Dr. Krudu was the PI in Moldova, and Dr. Leslie Scott and Wendy Stevens provided leadership at the Wits Health Consortium and NHLS in Johannesburg, South Africa, with Francesca Conradi overseeing the clinical site in Port Elizabeth. Right. I don't think I need to elaborate on the desperate need we have for accurate, reliable, and fast detection of drug resistance before initiating treatment for TB. Cepheid have now developed a new cartridge that can be run on existing GeneXpert platforms with a simple module swap to allow for reading of 10 colors. By computational analysis of melt curves, resistance can be detected against INH, ethionamide, fluoroquinolone, amikacin, kanamycins, and capreomycin within 90 minutes. The call for MTB is based on the detection of the INHA promoter and was seen to have a similar LOD as that for Expert MTB-RIF. A technical paper describing the assay development and performance was recently uploaded onto bioRxives. I will not discuss the technical elements here, but will rather focus on clinical performance for use of this assay as a reflex test upon diagnosis of MTB via routine testing. We performed a prospective diagnostic accuracy study of the Expert XDR assay at 4 sites, 2 in India, 1 in Moldova, and 1 in South Africa. We enrolled 710 symptomatic adult volunteers who had at least one risk factor for drug-resistant TB and a recent diagnosis of TB by either expert ultra or expert MTB-RIF. We enrolled both RIF-resistant and RIF-susceptible individuals. Each sputum was used for testing on the expert XDR assay, as well as smear and culture. And from those who were culture positive, we performed phenotypic DST testing, whole genome sequencing, and Hain line probe assays for first and second line drug resistance, as well as repeating the expert XDR assay on culture. Of the 609 participants with both valid expert XDR results and reference standard results, we found 79% were RIF resistant by either phenotypic DST or sequencing. This table shows the sensitivity and specificity for TB detection and each drug resistance call using a composite reference standard of either phenotypic DST or whole genome sequencing. Sensitivity for TB detection is excellent, while specificity is missing as the study design did not enroll TB negative individuals. Specificity was high for all drug targets, and sensitivity met our minimal criteria for each target, except ethionamide and caprimycin, which was 54% and 61% respectively. The lower sensitivity for ethionamide is based on the expert XDR assay only being able to capture ethionamide resistance-associated mutations in one gene region, the INHA promoter. And so other phenotypic ethionamide resistance mechanisms were missed by the assay. Caprimycin resistance is notoriously hard to detect accurately, as the molecular basis of phenotypic drug resistance is not well defined for this drug. Perhaps easier to interpret graphically, the figure on the left shows sensitivity, and that on the right shows specificity of the expert XDR assay against each drug target using the composite reference standard. The point estimates are indicated. Overall, sensitivity using a composite reference standard was about 5 to 10% lower for each target than if we had used phenotypic DST alone. This was mostly due to the whole genome sequencing detection of resistance mutations that were present in very low percentage of sequencing reads, but not detectable as resistant by phenotypic DST or expert XDR. Here we show the results based on the composite reference standard because of the overall importance of high specificity of this assay. Perhaps of most relevance is the comparable performance of expert XDR assay to the Hain line probe assays, except that expert XDR uses raw sputum and only takes 90 minutes to return a result. The higher sensitivity of LPA for TB detection can be expected given that LPA testing was done on culture and not on direct sputum specimen, as was done for expert XDR. And the higher sensitivity for INH in expert XDR is explained by the inclusion of 2 additional resistance-associated gene targets in the expert assay, FABG1 and AHPC. Otherwise, there is no difference in the performance between the 2 assays. Overall, and in conclusion, the expert XDR assay has shown high sensitivity for INH, fluoroquinolone, and second-line injectable drug resistance detection, with excellent specificity for all targets. And although ethionamide resistance sensitivity was low, this was not related to geographical location, and we see high sensitivity for the INHA promoter for ethionamide resistance. But given the limitations of ethionamide resistance detection here, perhaps the expert XDR assay is best to be used as a rule-in test only for ethionamide resistance. Also, expert XDR showed no difference in performance compared to the Hain line probe assays, except for INH given 2 additional INH targets. Overall, non-determinant rates were low, less than 3%, and user appraisal was very positive. The data from the study will form part of a package to be reviewed by WHO in December. This data is already very promising, and Cepheid has already launched the assay for commercial availability. Thank you for your attention, and thank you again to the PIs and the sites and all the staff involved, and of course to the participants and their families. And I'm happy to take questions now or by email later. Thank you.
Hello, everyone. I have no conflict of interest to disclose, and I present to you the diagnostic accuracy of Expert Ultra for childhood pulmonary tuberculosis in Uganda. Expert Ultra is a newer nucleic acid amplification test that has a higher sensitivity in adults with postbacillary TB. However, there are limited studies regarding its diagnostic accuracy among children. And so in our objectives, we set out to determine the diagnostic accuracy of Expert Ultra for diagnosing pulmonary tuberculosis in children and to assess the yield of Expert Ultra for unconfirmed tuberculosis. We also examined the role of Trace Expert Ultra results. And now looking at the methods, this was a prospective diagnostic accuracy study that was based at Mulago National Referral Hospital and surrounding hospitals and clinics in Kampala, Uganda. And we enrolled children less than 15 years of age who presented with signs and symptoms of TB between November 2018 to November 2019. We excluded children that had already taken anti-TB treatment or prophylaxis for TB in the last 1 year, or those that were not able to provide a respiratory specimen for evaluation. And further in the methods, we performed a clinical exam on each and every participant. We obtained their respiratory samples, placed their tuberculin skin tests, and evaluated both an AP and lateral chest radiograph. On the respiratory specimens collected, we performed Expert Ultra, fluorescent microscopy, and culture, both solid and a liquid culture for TB. So for all these participants, we reassessed them at 2 months and at 6 months for those that were actually started on anti-TB treatment. And now looking at the analysis, the index test was the Expert Ultra against the NIH consensus definition of confirmed TB, unconfirmed TB, and unlikely tuberculosis. In our primary analysis, we calculated the sensitivity and specificity of Expert Ultra based on confirmed TB as culture positive only and unlikely tuberculosis as per the NIH consensus definition. We also assessed the positivity of Expert Ultra among the unconfirmed TB cases. Yeah, so in our results, we enrolled 213 children over the 1 year study period, and 10.8% of them had confirmed tuberculosis, 41.3% had unconfirmed TB, and majority had unlikely TB. And the median age was 3.9 years, and majority were under 5 years of age. The HIV prevalence was 13, with a median CD4 cell count of 724 microliter, cells per microliter. And again, majority of the children were underweight. And now looking at the results, the sensitivity and specificity of Expert Ultra, we found Expert Ultra to be 69.6% sensitive among the children with confirmed TB and 100% specific among the unlikely tuberculosis. And when we evaluated its performance by the smear status, we found Expert Ultra to be 92.3% sensitive among smear-positive disease, and this dropped to 40% among smear-negative disease. And this is a significant sensitivity difference of about 52.3%. Yeah, and then looking at the yield of unconfirmed tuberculosis, 11% of children with unconfirmed tuberculosis were actually Expert Ultra positive. And when we categorized this, when we evaluated the performance of Expert Ultra against other reference standards, the composite reference standard, where unconfirmed TB was considered to be TB, you can see that the sensitivity dropped to 23.4%. And in the microbiologic reference standard, where unconfirmed TB was not TB, the specificity of Expert Ultra dropped to 94.7%. So from these findings, we can say that the sensitivity of Expert Ultra is somewhere between 70% and 23%, and 95 to 100% for the specificity. And this depends really on the reference standard in use. And looking at the trace findings, a large proportion, about a quarter of all the expert ultra results were trace. And majority of the children were HIV negative children under 5 years. And only one of the trace results was culture positive. The rest were unconfirmed TB. So what are the implications of our study? We were not able to perform the prior generation expert MTB-RIF assay, but based on the previous studies, we can say from our findings that expert ultra is about 5% more sensitive in children than the prior generation expert MTB-RIF. And expert ultra was able to identify up to 11% of children who had unconfirmed tuberculosis. However, we note that gaps still remain in the diagnosis of smear negative or clinical TB, and that trace results represent a large proportion of positive expert ultra results. Looking at strengths and weaknesses, the limitations. First, this was the first prospective evaluation of expert ultra in children. And we were able to enroll children from a diversity of cohorts. We looked at inpatients and outpatients, and children from tertiary and community-based settings. However, like said, we were not able to perform a direct comparison of expert ultra with the prior generation expert MTB-RIF. And we also had a low HIV prevalence in the study, and this prevented subgroup analysis. So in our conclusion, we say that expert ultra is a useful tool for diagnosing pulmonary tuberculosis in children, and trace results may play a significant role in finding culture negative TB. And we emphasize that a more sensitive diagnostic test is still needed to clarify the TB status in the majority of children with unconfirmed TB. I acknowledge the contribution of the investigators, who are also our mentors, and the study team, and the funders, and the Uganda TB Implementation Research Consortium, Makerere University College of Health Sciences, University of California, San Francisco, the Ministry of Health Uganda, the Infectious Disease Institute in Uganda, the Kampala City Council Authority, and PAT. Thank you for listening in.
Good day, everyone. I'd like to thank the organizers for this opportunity to speak, and I'd like to thank the attendees for watching. My name is Barry Kozloff, and I work for the London School of Hygiene and Tropical Medicine and Zambart in Lusaka, Zambia. The title of my presentation is External Quality Assurance of the Expert MTB-RIF Ultra Assay using Mycobacterium tuberculosis isolates inactivated in prime store molecular transport medium, a safe, simple, and local solution. I'd like to disclose one conflict of interest. Since May 2020, I've been a consultant for Longhorn Vaccines and Diagnostics based in Bethesda, Maryland, which donated the prime store MTM molecular transport medium used in this study. Next slide, please. Background: a robust external quality assurance system is essential to ensure high-quality expert MTB-RIF testing services and results. Some characteristics of an ideal expert MTB-RIF EQA system are: the samples should be similar to clinical samples, for example, sputum, and the testing procedure should mimic the standard expert MTB-RIF procedure. The samples should be simple and inexpensive to produce, preferably within the country where they'll be used. The samples should be non-infectious for safe transport, handling, and testing. The samples should be stable at ambient temperatures with a long shelf life so that cold chain transport and storage are not needed. The samples should yield accurate and reproducible test results. Next slide, please. Methods. 4 well-characterized mycobacterial isolates were grown in midget liquid culture: MTB drug sensitive, MTB RIF resistant, MTB INH resistant, and a non-tuberculous mycobacterium, or NTM. Culture medium was inactivated in prime store MTM, molecular transport medium, 1 part culture medium to 3 parts prime store MTM. Prime store MTM rapidly denatures all proteins and lipids and stabilizes DNA at ambient temperatures. The prime store MTM used in this study was donated by Longhorn Vaccines and Diagnostics. Each inactivated pool was tested using the Expert MTB-RIF Ultra assay. 1 ml of EQA sample was mixed with 2 ml of Expert sample reagent. All 3 MTB isolates were MTB detected high. The NTM was MTB not detected. Each inactivated pool was aliquoted into tubes, 1 ml per tube, and stored at ambient temperature for periodic expert testing over the course of 1 year to assess stability, accuracy, and reproducibility. Material from each inactivated pool was inoculated into midget liquid culture and incubated to confirm that the isolates had been successfully inactivated and the EQA samples were non-infectious. Next slide, please. Results. All 4 mycobacterial isolates inactivated in prime store MTM were negative for growth after 84 days in culture, confirming that the EQA samples were non-infectious. The Expert MTB-RIF Ultra assay results at 0, 2, 4, 6, 8, 10, 12, 16, and 24 weeks showed stable CT values despite storage at ambient temperature. MTB was correctly detected in all MTB isolate aliquots. The NTM aliquots were correctly identified as MTB not detected. RIF status was accurately identified in all samples. The cost to produce the EQA samples was less than $4 per sample. Next slide, please. I'm going to show 4 graphs, 1 for each isolate, displaying CTs at the 9 time points tested so far. The first graph is for the MTB drug-sensitive isolate. Pay special attention to the red line just above a CT of 15. This represents the CTs for the MTB-specific insertion elements, which remain stable from baseline through 24 weeks. The CTs for the specimen processing control, or SPC, and the 4 RPOB probes also remain stable. The expert results listed along the bottom of the graph are MTB detected and RIF resistance not detected at all time points. Next slide, please. The second CT graph for the MTB RIF resistant isolate is similar to the MTB drug sensitive graph. The CTs are stable and the MTB is detectable at all time points. The only difference is that RIF resistance is detected at all time points. Next slide, please. The third CT graph for the MTB INH resistant isolate is similar to the MTB drug sensitive graph. The CTs are stable and the results are MTB detected and RIF resistance not detected at all time points. Next slide, please. The fourth and final graph shows CTs for the NTM. The results are MTB not detected at all time points. Next slide, please. In conclusion, MTB isolates inactivated in prime store MTM molecular transport medium remain stable at ambient temperature for up to 24 weeks. More recent testing confirms stability up to 32 weeks and can serve as the basis for a safe, simple, cost-effective, locally produced, accurate, and reproducible EQA system, the Expert MTB-RIF assay. Next slide, please. Future studies. Since prime store MTM is compatible with assays and test platforms using silica or magnetic particle extractions, we will perform validations to demonstrate that the EQA system is applicable to other TB molecular assays. We're developing a similar system for TB line probe assays and other molecular assays that don't include extraction steps. Planning is underway for a pilot study of the EQA system at 15 Ministry of Health Expert MTB RIF testing centers in Zambia. Thank you very much.
Hello, everyone. This is Mulalem from FIND Geneva office, and I'll be speaking on a combination of expert and TB assay improves the diagnosis of extrapulmonary tuberculosis in Ethiopia. When it comes to introduction, as you know, TB is a contagious disease caused by a group of bacteria called Mycobacterium TB complex. Every year, TB causes millions of deaths and morbidity. Basically, TB affects the lung, but still it can affect any organ outside the lung, which we call it extrapulmonary TB. And extrapulmonary TB can have different manifestation. It can affect the lymph nodes, the peritoneal, the abdomen, the CNS, and other body parts. Ethiopia is one of the 30 high-burden TB countries for TB, TB-HIV, and MDR TB. More importantly, Ethiopia has very high rate of extrapulmonary TB. About 1/3 of all forms of TB is extrapulmonary TB in Ethiopia. Despite this, diagnosis of extrapulmonary TB remains very challenging for a number of reasons. The variable non-specific presentation, extrapulmonary TB can have different manifestation, the post-bacillary nature of the disease, the non-uniform distribution of the bacilla is a clinical sample, and also it's difficult to obtain a clinical sample from different parts of the body. And the most important one is the currently available diagnostic tools are either they are low in sensitivity or they may lack specificity. All these lead to misdiagnosis with increased morbidity and mortality. And in some cases, it may also lead to unnecessary treatment because of the non-specificity of some diagnostic tools for extrapulmonary TB. In 2010, WHO has endorsed expert for diagnosis of TB and rifampicin resistance. Then after, in 2014, WHO has revised the recommendation, and also WHO recommends expert for some form of extrapulmonary TB, including the lymph node and CNS TB. But however, still we need more data on performance of expert for different type of extrapulmonary TBs. Likewise, WHO also recommends the rapid point of care test, which we call it determined TB LAM assay for diagnosis of TB, especially in HIV patients with immunocompromised individuals. LAM actually provide a rapid result within 25 minutes, which is one advantage of this test. Therefore, in this study, we are aimed to evaluate the diagnostic performance of the gene expert and TB LAM assay for prompt diagnosis of extrapulmonary TB in Ethiopia. When it comes to the materials, for this study, we included a total of 147 clinically presumed extrapulmonary TB patients visiting our specialized hospital, which is Jimma University Specialized Hospital. And from these 147 patients, we collected site-specific clinical samples. This is actually as part of routine diagnosis. We collected about 28 CSF samples, 49 peritoneal fluid, 45 pericardial fluid, 19 lymph node abscess, and other clinical samples. In addition to this, we also invite our patients to provide urine sample, and only 126 patients has provided urine sample. And actually, the collected clinical samples were tested for a gene expert, culture, and for some microscopy, and the urine sample were tested for TB by using the determined TB LAM assay. In addition to this clinical sample, we also review our patients' record for clinicians' decision whether they start anti-TB treatment or not, and also we also document their treatment outcome, which is very important to classify our patients into different categories. So based on the lab diagnosis and based on the clinical criteria, we classify our patients into 3 groups. 23 patients were confirmed TB cases. These were culture positive. 14 patients were culture negative, but clinically classified as TB case based on a positive response to anti-TB treatment, and based on their treatment outcome, we classify this as probable TB patients, whereas 110 patients were classified as non-TB cases. They were microbiologically negative as well as clinically non-TB cases. Of patients tested for HIV, 23, that means about 15% were HIV infected. When it comes to the result and discussion part, so our interest is actually to calculate the diagnostic performance of expert and LAM assay against culture and composite reference standard. As I've said, the composite reference standard consists of the culture and clinical criteria. So when you see the sensitivity and specificity of LAM has in general low sensitivity for diagnosis of extrapulmonary TB. It was like 33% against composite reference standard, and it was 35% against culture. This means the LAM has low sensitivity. That means a negative LAM cannot exclude extrapulmonary TB diagnosis. When you see the sensitivity of expert against culture, it is like 69%, but it has low sensitivity when we compare with composite reference standard. But the most important thing is the combination of LAM and expert has significantly higher sensitivity. It's like 82% against culture, and it is 61% against reference standard. Another interesting finding is we also try to see LAM and expert sensitivity in HIV positive and HIV negative patients. So as you can see from this diagram, expert has like 50% in HIV positive and 35% in HIV negatives. But when it comes to the LAM has higher sensitivity in HIV positives. This is actually in line with other findings from the different parts of the globe. And the most important thing is combination of expert and LAM has significantly higher sensitivity in HIV positives compared to HIV negatives. Our third objective is also to see how expert performs across different clinical samples. So as you can see from this table, expert has heterogeneous sensitivity across the different type of extrapulmonary samples. It has higher sensitivity for lymph node abscess, moderate sensitivity for CSF sample, but very low sensitivity for fluids, especially for pleural and pericardial fluids. That means it's actually good to optimize the use of expert depending on the type of clinical sample. So we recommend expert for lymph node abscess, but not for pleural. The conclusion part, expert test had higher sensitivity for abscess, but low sensitivity for body fluids, especially for pleural fluids. LAM test had high sensitivity for diagnosis of TB in HIV co-infected individuals compared to HIV negative one. And the most important thing is that we suggest that it's better to use the combination of expert and LAM test than using them alone. This is what we find from this clinical study. And finally, I would like to thank our study participants, Jimma University, for funding this study, FIND, and also Union Conference for supporting me to make this presentation. Thank you.
I'd like to thank the Union for giving me the opportunity to present our results. The partners involved in the study were also the sponsor of the study. However, they were not involved in the study design, the analysis, or the interpretation of the results. Today, I'm going to present to you results from our comparative analytical evaluation for 4 centralized platforms for detection of tuberculosis as well as resistance to rifampicin and isoniazid. I would like to thank all the partners involved who made the study possible, especially our collaborators in Johannesburg, South Africa, Professor Wendy Stevens, Professor Leslie Scott, and Anura David. I'm going to start with an introduction on the 4 assays that we evaluated. These are high throughput centralized assays that are intended for use in reference laboratories. As you can see, they're listed as one from Abbott, BD, Roche, and then Life Science. And as you can see, they target very different gene targets for TB detection. Some of them using multi-copy targets and others use single genes. Secondly, I want to highlight that for the assays for Abbott and for Hain, the DNA extraction and PCR and application is done in 2 separate instruments. Then secondly, for Abbott and for Roche, the assays, the resistance is only done as a reflex assay on MTB positive samples. And lastly, for BD, the throughput is much lower than for the other assays. However, you can easily do 2 runs in an 8-hour workday. So the objective of the study was to firstly estimate the analytical sensitivity for TB detection using expert NTB-RIF as our comparator. And secondly, we wanted to estimate the accuracy of the assays to detect rifampicin and isoniazid resistance using the line probe assay as our comparator. So the methods for the limit of detection study, we used the chemically inactivated panel, which consisted of H37RV and M-Bovis. And the reason why we selected these two is because they have different copies of IS6110. And this will allow us to see if this has an influence on those assays that target as IS6110. We then spiked these in TB negative sputum in a 3-stage experiment where we want to determine the concentrations that are best for the LOD experiment. And this experiment then consisted of 20 replicates tested in 5 concentrations with negative controls. We then determined the limit of detection by using the Poisson binomial probability model, where the LOD then corresponded to the 95% hit rate. And we did all assays according to the manufacturing instructions. I want to highlight now that because this panel was not designed to estimate the exact LOD, you will see that the results that we got is not really what you would expect and is what is reflected in the instructions we use for some of these assays. As you can see on the slide, I'm showing the limit of detection in genomes per mole for the 5 assays. For the assays that target multi-copy elements, we saw an increased sensitivity for TB detection for H37RV compared to Bovis, as well as compared to expert NTB-RIF. And this is because there's more copies of IS6110 in H37RV. For Roche, we saw a slight increase in sensitivity, and this could be because this assay targets 16S as well as 5 ESX genes. And then for Hain Life Science, we saw a decrease in sensitivity, and we have 2 hypotheses for this. The one is that this assay targets only RPOB, where the others target more than one gene or multi-copy elements. And secondly, we hypothesize, or we think that there may be some free DNA in the panel that we used. And since the instrument from Hain Life Science does not capture free DNA, we believe this may be a reason for the difference in the LOD observed. Then for the detection of resistance accuracy, we selected strains from our fine specimen bank. And this included strains with various mutations in RPB, CAG, and INF promoter. And these mutations also occur at different frequencies in the global resistant population. We then tested these strains in triplicate, full assays, and once by the line probe assay. We then calculated 2 scores. The one is a simple proportion score, which is the overall mutations detected as a fraction of the total mutations tested. And secondly, we determined a weighted sensitivity, which is the number of correctly detected mutations weighted by the frequency that they are found in the resistance population. So these are the results then for the 5 assays. And as you can see, in our panel, the line probe assay performed near perfect. For Abbott, the assay missed 3 mutations in the RPOB gene. These mutations are, however, quite rare. For BD, the assay missed all replicates of the KG-S315N mutation. And this mutation is actually listed in their instructions for use to be detected. However, it was missed in our study. And then for Hain, the assay missed 1 replicate of 2 RPOB mutations, which are also quite rare RPOB mutations, and then also the same CAG mutation that was missed by BD. For Roche, the assay missed all replicates for 2 RPOB mutations. The one is actually 2 codon deletion, which is also a very rare RPOB mutation. And then it missed 1 replicate of one of the resistance strains for isoniazid resistance. So in conclusion, our key findings are that the accuracy of these assays are very similar to what the line probe assay is. And secondly, we believe that the analytical sensitivity of these assays are similar to expert NTB-RIF or slightly better in sensitivity. And this is despite the limitations that we have observed in our panel, as well as how complex these experiments were to do in these 5 instruments as well. We do believe that the data is complementary to what we've seen in the limited clinical studies that have been done for these assays. If we can show that these assays have high accuracy and it's recommended by WHO for use, it means that high burden countries will have more testing options to improve case detection and resistance testing for TB. And especially because some of these assays are already in use for other diseases, it may make sense for some countries to adopt those instruments as well for TB detection. And then lastly, because these assays appear to have very similar performance for MTTB detection as well as resistance detection, countries will have to determine the best fit for purpose, accounting for TB burden, background, epidemiology, HIV co-infection, as well as other operational aspects. I thank you for your time.
All for the very, very nice presentations, and the floor is now open for discussion. We already received very good questions through the platform, and I thought we can start maybe with Dave on the TrueNAT. There were a few questions for you around the cost and the low, whether it could be used in the low research settings. So maybe I first give you the floor, and maybe you have other questions you would like to answer at the same time.
Thanks, Petra. I think those for Adam. Could you repeat the question?
Yes, sorry, I have the name. Yes, please, Adam. Can you go ahead? Thanks.
The question was about
the question was about the cost and how convenient it is to use the TrueNAT in a low research setting, because these are questions that came across. So maybe you could give some answers. And again, sorry for the name.
No problem. Thanks, Petra. So the cost of the assays, I mean, obviously there's a cost for the instrument and the cost of the assays. MolBio have said over and over again that they would come in at a cost that's lower than that of what the Expert Ultra cartridge is. Find is not involved in the commercialization of the assays. We help with the development, bringing it through the regulatory hurdles, of course, independent evaluations to bring forward into the market. But we are not involved in the commercializations. And although we do work to keep the price low and try and negotiate those, it's not our role. So I think the best thing to get a concrete answer is to speak to MolBio directly. They do have a booth, a virtual booth that you can visit as part of the union, and I'm sure they'll be happy to answer the questions. And I also, just to say that the TrueNAT assay has 2 components. There's the TruePrep, which is done for the DNA extraction, and then there's a TrueNAT micro-PCR. So you can get a TrueNAT Uno, which is a single chamber, or a Duo, or a Quattro for 4. So I think that the instrument price does change at the higher capacity, but all are portable. And I think that leads to the second part of your question about user appropriateness. And we did do a study to see the user acceptability using an earlier version of the assay, and it was well received by the operators. But there were some design changes, and those designs led to the assays that we used in this trial. So I think it has been well received. Sorry, there's a lot of echo on somebody. Let me just make sure that the microphones are muted on our side. I think it has been well received, and if with the appropriate training given and videos, I think the users felt quite comfortable with the operations after a little bit of experience. I hope this answers the question.
Yeah, that absolutely answers the question. And I think we are all quite curious to see how it is rolled out in the countries, of course, the TrueNAT, as it will be a good one for getting out of the monopoly of the expert machine. I mean, we all know about that. And maybe, Dave, you had another question to Adam, or shall we move to the next presentation?
Let's keep moving.
Okay, that's fine. So then we have for David, I saw many questions also passing by on the Fujilam. And I think Fujilam is really very nice that we get more presentations in this union conference, I think it's a very good improvement to the LAM as we have it so far. So Dave, I would like to give you the floor, and maybe you have some answer to your questions. I saw something about using Fujilam in CSF, but also questions around the NTM again, of how much you can distinguish between that. And I would like to also see whether it's a complement test to a stool when you use it for children. So maybe you can elaborate a little bit on that.
Great, thanks. And yeah, I'll just say overall, this is exciting findings. The fact that we're able to almost over double our sensitivity for LAM really supports that we're heading in the right direction, definitely for children, which is greatly needed. So yeah, for CSF, to my understanding, Fujilam is largely focused on urine, and that's how the assay has been developed. But I think overall, CNS TB is a huge problem. And so finding markers for extrapulmonary TB, including CNS TB, is really important. In terms of the NTM, and I think also Tobias had a question related to the idea of kind of some of the false positives that we had. All these children were followed up for at least 2 months if they weren't started on treatment. And if they were started on treatment, we followed them for the full 6-month standard course. And we didn't have any NTM cases, and all the follow-up didn't suggest that they developed TB, and actually all resolved their symptoms without any treatment. And so there are limitations that we didn't evaluate for extrapulmonary TB specifically, such as doing urine ultra to look for renal TB. We also didn't evaluate for other bacteria that, for example, a Lear lamb has been shown to cross-react, but these were all spontaneous void samples, and at least the urinalysis did not suggest that they had it. So I think further work needs to be done to better characterize the specificity. But I will say it was only, absolute-wise, it was only 4 cases. And then in terms of the stool question, I'll just highlight that as a group, we are looking in partnership with FIND at the stool processing methods in order to look at stool-based testing for TB in children. Yeah, I think in both cases, the specificity seems to be good. It's really kind of how do we come up with methods to improve our sensitivity, especially if we're looking for initial triage tests. So I think they'll both be helpful, but I think especially in childhood TB, trying to come up with methods to improve our sensitivity will really be a priority.
Yeah, thanks, Dave. And I think this is really interesting. And I do agree with the follow-up of those children. That will also help us much better to understand what these diagnostics really mean, isn't it? I think that's really something that is very crucial in this kind of research and finding out the essentials of the diagnostics. Anything to add from your side, Dave?
I really just wanted to ask about study design. You have 35% of your cohort who had confirmed TB, which is quite high. So it's quite a sort of enriched population, do you think, rather than a sort of typical spread of kids who will be evaluated for TB?
Sure. I mean, I think we, one, in terms of our population, the children that are coming into a pediatric TB clinic specifically, so just in terms of their flow, they're being referred in from a variety of places that might have already gone through initial evaluations and then ultimately, had a higher concern or risk. And then I think it also just speaks to the strength of the study in that we didn't just refer from the one site, but really through a variety of clinics and hospitals throughout the Kampala area that we built kind of strong relationships to, that if they had cases that they were concerned for TB, they connected with us. And so I think that we benefited from having a good network to improve our confirmed rate, which, as you note, is always a challenge.
Mm-hmm. Yeah, thanks. So then let's go back to Adam. Thanks a lot, Devon, for your very clear answers. Adam, I would like to give you the floor again because of the XDR cartridge, and which we are all really looking forward to, isn't it? And we hope that these results, as they look very excellent, will help us also to start rolling out this test. So maybe you could answer some of the questions. I saw questions about the cross reaction of the 10 colors, and there were quite some other questions that you might like to answer.
Great, thanks, Petra. I think the question about the cross reaction on the 10 colors, I don't know if everybody read it in the chat, but it was a query as to whether there would be overlap for detection of different primers in the different colors, and whether that might have lowered the sensitivity. And I'm not sure if I can answer that technically. There is a technical paper that was published on bioRxives that might have a bit more information on that. But I think overall that the 10 colors have been quite effective in terms of their performance. We did see high specificity, and I think there was a query as to why was the specificity so surprisingly high. Maybe the answer to that is because of the robust reference standard of whole genome sequencing that we use to look for resistance mutations. So I think that really did help identify the high specificity. I don't know if that's answered the question directly, or if there's something more specific about the 10 color modules versus 6 colors.
No, I think that I did answer the question. And there was also some other discussion. And I also am quite curious to know whether the XDR cartridge can be done at each expert site, or is this more the idea that it will be used in the central level? So that maybe you can say something about that as well.
Right. A great question. I think it's very relevant. At this point, it is still a centralized assay. And also importantly to state that this is still designed to be a reflex test. So once you have a positive ultra result, and that's how the study was designed. If you have a MTB detected in the ultra, then you would be reflex. So I think it is intended to be used as a reflex assay. And there's been a lot of talk about Omni coming one of these days. That, as far as I know, has not converted to 10 color at this point. But of course, it would be wonderful if we could move that way. Just one more comment about the modules. I think it is quite easy to do a swap of existing 6 color modules for the 10 color modules. And so the idea is that there would be a new purchase of these 10 color modules, which of course could still run the old ultra cartridges as well. And I think Cepheid is offering a buyback of the old 6 color modules in that replacement.
Okay, thank you so much. I see Dave has also one question. Please go ahead, Dave.
Yeah, time doesn't really allow for it, but it's really throwing the cat amongst the pigeons slightly. For many years, we battled with labs doing phenotypic DST on ethambutol and streptomycin for all strains, which was just redundant testing for the vast majority of strains. One looks at aminoglycosides in the Expert XDR cartridge and wonders whether or not that's adding enough value to have them included now that the aminoglycosides really have fallen from favor.
Yeah, thanks a lot. Yeah, for the question. I think we also need to move as we have 10 minutes, but please go ahead quickly to answer the question, Adam.
Absolutely relevant. Thanks, Dave. And I bet that was what it was designed at the point, and it takes a while to get there. Hopefully in the future, they'll be able to do a switch out of some of the primers, but at this point, the approval is based on what we have.
Okay, then let's move quickly to Peter. I think you had an excellent presentation. And there were some questions with you about whether those children that have very possible disease, of course, and you're saying that you had 11% more cases found in this unconfirmed group. So could you maybe say more about that? And is there any other question you would like to answer that you have seen in the chat? Go ahead, please, Peter.
Thank you so much. Will you come again? I didn't get the question very well.
So what I saw is that you had 11% more cases found through using the Expert Ultra compared to in the unconfirmed cases. Did I understand that correctly?
Oh, yes, yes, that is true. When we enrolled our patients and obtained samples, for all of them, we did culture, both liquid and solid culture. And they were classified according to the NIH consensus definition, but confirmed TB was considered to be culture positive. So then the unconfirmed TB was arrived at by an outcomes classification team, and then unlikely TB. So for those that didn't have, were not confirmed TB, but classified as unlikely, when we ran their samples and tested for expert, we found that most of them were negative, but 11% were actually positive for TB. They also had signs and symptoms of tuberculosis, and other clinical evaluations suggested that they had TB, but the 11% really strengthens the fact that Expert Ultra is able to catch more TB that is classified as unconfirmed.
Thanks a lot. Yeah, some people didn't really get the question, but I think there's always the discussion about culture and expert, and the discordance between those, especially around this possible disease. And I think this is what you confirm now, that you were able to find 11% more cases by Expert Ultra that were unconfirmed cases, if I understand correctly, by culture.
Yes, that is.
Okay. So I'm just looking at the time, I'd just like to move forward. I want to go to Barry. Barry, I'm not sure if you were able to get your questions, but one of the questions was, is there enough evidence that the heat-killed isolates degrade without the preservative? So, because I think that's one thing you were mentioning.
Yes, so I think that's an excellent question. The main reason for using Prime Store is in order to prepare large batches with little variability. And if we produce batches in 50 mils or more, potentially it could be scaled up to a liter or more. And Prime Store has unique properties. It disrupts all the lipids and proteins, so you get a homogeneous preparation. And that way there's going to be little variability from sample to sample. If we did it heat killing, I don't know how you would heat kill a liter of solution at one time. And you would probably get a lot of clumping. And when you aliquot it, you would not have a consistent preparation. So we were trying to use the properties of Prime Store to get that homogeneity. And I think that's very important. And also that way we feel confident that it is non-infectious and it is consistent over time from aliquot to aliquot. I hope that answers the question.
No, it does, and thanks a lot. And it's interesting to know that as it preserves the DNA, finally you experts should pick up whole cells and not the DNA at itself, they say, but there's some discussions around that.
That's, yeah, we've been having this argument for quite a few years now.
Yeah.
It works. I think people just have to admit that it works without the cells being there. And we've been doing this over and over again.
Thanks, Barry, a lot. And there were many more questions, but you can answer them in the chat, and I will share them also to everyone. So I would like to go to Mululu. I'm sorry, I'm pronouncing your name not correctly, probably. Thanks also for the very interesting presentation. And I had one question was, did you use other samples than urine? And the other was also cost expert LAM for the combination of the two tests for extrapulmonary TB. And I think it's a very interesting topic that you touched.
Okay. Can you hear me?
So one of the questions was, what is the cost, the extra cost of expert LAM for extrapulmonary TB? So when you have the combination of the two tests, and did you use other samples than urine for your LAM test?
Okay, thank you for the great question. The point is actually when you combine both expert and LAM, the cost is a bit higher. But if you compare the cost of LAM and expert using together as compared to culture, for sure the cost is a bit low. In our study, we can see that the performance of LAM and expert using together is equivalent to that of culture. And the other advantage is, using these rapid tests, we will allow us to early diagnose TB case so that we can initiate patients on time with anti-TB treatment. That is the thing. The other, for the second question, also another interesting question. We didn't do actually LAM on other body fluids. We do LAM for urine, and so far, as far as my knowledge is concerned, LAM test is optimized on urine sample. But when we stratify, when you compare LAM test result with other type of extrapulmonary TB. Lung positivity is more higher in a form of TB, you call it pleural TB, because these patients having pleural TB are more likely to have probable TB. These patients we are actually unable to even get them with culture, but LAM can detect those clinically, but bacteriologically unconfirmed TB cases.
Okay, that's very nice that you have explained it so well, and thanks a lot. I just looking at the time, there's only 2 minutes left, so I really like to move now to Margarita, and we will post your questions to you so you can answer them also further. Is that okay? Thanks a lot. So Margarita, I'm not sure if there was one question for you, but I'm not sure if I've picked it up. I think you have seen it maybe yourself. Is there? I'm just going to try to see.
I can find it. So Richard Anthony was asking if this data is published, Margarita.
So it's under review currently, and then all the assays will be evaluated at the WHO in December as well.
Thanks. So I think we have to almost close now. I don't know if there's much more time left. There's some new messages coming in, and I think it's only 1 minute left. So I think I have to thank everyone for the fantastic presentations and all your time, and also for the speakers. And there were quite a lot of audience, so we really have reached many people. Thanks also to Dave and doing this together. This was really nice we could work together like this. And I think that we will post those questions further, and we will discuss it further as well. And we, yeah, thanks again for everyone. Big smiles. That's what they ask us to do now. Yeah.